You press the power button and wait. Black screen. A logo. A spinner going nowhere. This machine does billions of things a second. So why is turning it on the slowest thing it does? Because the moment the power dropped, it forgot everything. It doesn't even know where its own operating system is. Your RAM is wiped blank the instant the power drops. Nothing waiting in memory to run. The processor wakes up just as empty, hardwired to check one address first. On a PC, it's this. The most powerful chip you own boots up knowing exactly one number, one place to look. And when it looks there, it doesn't find your operating system. It finds a tiny chip that's been sitting on your motherboard, powered off, waiting for this exact moment. That chip is the firmware, UEFI on a modern machine, BIOS on an older one. It lives on flash memory, and flash has one power the rest of your computer lacks. It keeps what it holds with the power off. That's why it goes first. It's the only code guaranteed to still be there the instant you hit power. The firmware is a tiny skeleton crew, and its first job has a name, Post, a power-on self-test. Wake the essential hardware, count the RAM, check that the CPU and the drives are actually responding. And notice the order. It has to get memory working before it can load anything into memory. But the firmware is tiny, just a few megabytes. It's nowhere near your operating system. So its real job is to go find it. So the firmware goes hunting. It keeps a list, a boot order, of where to look, and it walks to a special reserved spot on your drive, a little partition set aside for exactly this. There it loads one small program, the bootloader. The bootloader has a single mission: find the kernel, the core of your operating system, the beating heart of Windows or Mac OS or Linux, and haul it off the slow disk up into the now working memory. Watch the handoff. Firmware wakes the body, the bootloader finds the brain, and then it steps aside and hands over control. For the first time since you pressed the button, your actual operating system is running. You would think the hard part is over. You are not even close. And the kernel wakes up to a dark house. It has a processor and memory, but it can't talk to your screen, your keyboard, your Wi-Fi, your disk, not yet. For every piece of hardware, it loads a driver, a little translator that speaks that device's private language. Screen, sound, network. One by one, the lights come on. Then it mounts your file system so it can finally read the rest of itself and does the one thing everything else waits on. It starts the first program. Just one. Linux calls it System D, a Mac, Launch D. Windows hands off to its Session Manager. And every program you'll ever open, your browser, your games, this video, is a descendant of that single process. Its job, wake up everyone else. Here is where your 30 seconds actually go. That first process starts the background crew, the services, networking, sound, the login screen, security, search indexing, Bluetooth, dozens and dozens of them, each its own little program. And they cannot all start at once because some of them need others to be up first. You cannot log in before the service that checks your account is running. So they come up in order, a dependency chain, a cascade, each one fetched off the disk and switched on. That spinner you're staring at, It is the machine standing at the door, waiting for the whole crew to file in and report ready. But hold on, these are just programs starting. Your computer starts programs instantly all day long. So why does starting these take the better part of a minute? Because the holdup was never the thinking, it's the fetching. Every layer of this, firmware, bootloader, kernel, every driver, every one of those services has to be read off your storage and carried into memory before the processor can run a word of it. And reaching your disk is the slowest move your computer makes. Picture it on the scale from before. If reaching memory is a glance at the notepad on your desk, reaching a spinning hard drive is standing up, walking across town, and coming back for one file. And starting up is thousands of those trips. That's the whole answer. It's why the same computer boots in seconds off a solid-state drive and drags for a minute off an old spinning one. Same programs, slower shelf. It's why a machine stuffed with startup apps crawls, more to fetch, one slow shelf. The wait was never the computer being slow to think. It was the computer building itself off the slowest thing it owns. So look again at that black screen. That wasn't your computer being lazy. In those 30 seconds, it woke up knowing a single number, found the one chip that never forgets, taught itself to speak to its own hardware, and built its entire software world from nothing, in order, off the slowest thing it owns. There's a perfect word for it. To boot is short for bootstrap, to pull yourself up by straps you don't even have yet. An impossible trick your computer pulls off every time you press the button. Which is why it cheats when it can. When Windows Fast Startup is on and you shut down, it doesn't tear this world back down. It saves a snapshot to a file and just reloads it next time. Sleep does the same. The fastest way to build a world is to keep one you built earlier. So the next time that spinner just won't stop crawling, you know what it's really doing back there, building a whole world up from nothing, one layer at a time.
Everything you just figured out rests on something deeper, and that's the next video, so start there. Would you rather understand your computer than just use it? Then subscribe, and I'll see you next time, further down the stack.